maybe we'll start by introducing ourselves. So my name is Omri Alush. I teach the deep learning course here, which is in the second semester. So there's a lot of gearing up towards that. Obviously, I think many of you probably decided that you want to learn more about data science because you've seen what deep learning is able to do these days. I also teach data science at Bar-Ilan University, at the Faculty of Engineering, where I try to tell students not to use deep learning as much as I can in the beginning. And I will also say the same thing to you, but give you the background and knowledge of how to use it and when to use it. I had the research department in a startup called Gone. It's not really a startup today. I joined 2.5 years ago as the second data scientist. Now I manage a team of 10 in a company of 200 plus people, so growing very fast. And that's about it.
So hey everybody, it's nice to see a lot of new faces and some old ones from last year. My name is Segev Arbiv. I'm a data scientist at a company called SimilarWeb that some of you might are familiar with. The company's objective were trying to apply machine learning algorithms to get insights from traffic around the web. Before that, I had experience. I was developing algorithm that related to computer vision and image processing. The final product might be different, but you will get to know that there is a lot of overlapping between the machine learning algorithm that we are using in the day-to-day basis. We're going to meet each other again really soon. I'm going to be the lecturer of the unsupervised learning part of the course. In there, we will see how we can actually exploit and take advantage of the structure of the data, where it can become really efficient and effective when we don't have the data tagged or labeled. And as Omri said, deep learning is great, and a lot of approaches are great when you have the final label, but it's sometimes relevant and super important to get to know your data from within, and that's what unsupervised learning is all about. And let's have an amazing year.
So hi, I won't spend too much time because you probably all already know me. So my name is Gleb and I'm teaching Python for data processing. That's like a foundational course together with probability to get you all ready for upcoming courses in all over machine learning. So basically you will learn a lot how to write novels, but I will teach you the alphabet, basically. That's the goal of this course. So everything else you probably remember from lectures, so I won't spend a lot of time. Thank you.
Hi, I'm Amir Globerson. I'm a professor of computer science at Tel Aviv University. And part of my involvement with Yandex is due to a very generous support of Yandex for machine learning activity at Tel Aviv University. And I think we have a great group of faculty there. I teach machine learning at the university, so I also know this material, and I guess I've been doing this for 20 years now. And the field has really evolved tremendously. I mean, it's amazing to see what's been done, but I think it will be equally amazing to see what will be done in 20 years from now. There's so much we can't do still, so don't feel like it's all been done. It's just a technique from now on. There's still much more to explore.
Great. So hi, my name is Yuri Lebaev. I'm a consultant. I'm doing consulting for companies, mostly traditional companies who want to implement AI solutions. And I founded a community called Machine and Deep Learning Israel, one of the leading community in Israel in this field. And that's it.
So the first question to the panel is, why are we torturing the students so much right now? We see huge improvements in deep learning. There are modern frameworks that allow us to pretty easily have abstractions and import pre-trained models, do some tricks, maybe even optimize the hyperparameters for us and get pretty cool results. Is there really a need to learn the basics, the fundamentals? How important is it for an aspiring data scientist to know probability, to know the mathematical principles around those things? And if so, And if you think this is important, is it always important, or maybe you think there would be some divergence in the actual jobs of some people that know the math and some people that don't and manage to do well with that? Who wants to go first?
Well, first I can say from personal experience, I've seen a lot of students sort of before and after taking courses, or people who have formal education in this field or not. And I think there are dramatic differences. We're still at a point, and I think we will be at a point for a long while, where it's really important to understand the fundamentals of this field in order to do things, the practical stuff, correctly. So there are many sort of pitfalls that you get into if you don't understand. I mean, let me just give you one example. It's sort of silly, but let's say I often see this. People come, they say, okay, we want to classify between class A and class B, and they say, okay, we trained this huge neural net, we got accuracy of 90%. It sounds great, right? So what's the problem? What's the potential problem? Right, that there's one class that there's 90% of the data that's one class, 10% that's the other. So if you just say it's class A all the time, you get 90%, right? It sounds fantastic, but you've done nothing, okay? So that's a simple example, but there are many things like that in the area of understanding overfitting, optimizing for the right metric, things like that, where you can easily fail, and you see this all the time. So I think that's really important. That you don't understand these things if you don't understand the basics. So I think it's really important at this point, and probably for much longer. Another point is that there's this thing in learning theory called the no free lunch theorem. Have you heard about that? So it basically says you can't build a learning machine that will always succeed, that can learn anything. Okay, and that no free lunch, I like to say, is a free lunch for us, the scientists, because it means that there's a place for us, right? There's no perfect AutoML. Okay, it provably does not exist. So that proves that you need to understand what you're doing, basically.
I mostly agree. I think it depends on what you're trying to solve. Google just launched, I think yesterday, a new service called Teachable Machine. If you saw it, it actually lets you, it's like, I call it the weeks of machine learning. Just drag and drop, click play, and you have your own ready model. So for most of the use case or most of the POC, I think you can do really fine without having too much math or even too much code for nowadays. But when you're trying to tackle a real problem in real life, then you understand why you need this extra knowledge, when you need to go deeper for the math or to the theory. So I think that in the beginning or for very basic task, differentiating between cat and dog, for as simple as it gets, you don't really need the heavy lifting. But if you want to do this specific task, and want to improve from 90 to 99, then you need to go much deeper. So I think it depends on what you want to do in your career. If you wish to do more of the same or helping build something that is really known and solved, and this is okay, you can do amazing stuff by doing that. Or you want to go to this extra mile in those 10% top that maybe will be much difficult, much interesting, but you will need to know much deeper math and all the theory around it.
Okay, so another aspect to this problem is probably the speed with which the field is evolving. So each year you have something new, so there are GANs, then there are capsule networks, then there's neural ordinary differential equations, then there's graph networks, and so on, and so on, and so on. So it's hard to follow this even for some professionals, and it's especially hard to follow all of this if you do not have strong background and knowledge of fundamentals. Although, of course, you can read papers and all of that, but it's much simpler if you see the repeating patterns in different areas and you can easily and quickly grasp any new technology. The alternative is that you take it all as technical. Okay, someone developed new GAN, so we take something pre-trained and apply it to our problem. And then you will have to do the same again and again and again, and you'll always in a rush trying to get to speed with the technology advancement. And another viewpoint on this is that you will definitely miss almost all new things if you do not know fundamentals. Because when you see the patterns, you kind of can try to imagine the corridor where anything can go or cannot go. When you always apply it as just an engineering discipline, it's always like that's what we have now, and we do not know what will happen and what can or cannot happen. So it's important. It makes life easier. Of course, it's hard to read papers because it takes some time. You need to get all the math if there is a lot of math. But that's valuable, and it pays off really well because it's much easier to be like on a speed with the industry.
So it's going to be really hard not to repeat all what has been said right before me. As a big fan of fundamentals, I really think that it's super important that you will have those core mathematics fundamentals behind. And why is that? The pace of research papers that are going in the past year, like the publication, is going exponentially. And I can't keep up with the pace, and neither am I trying. Because as said before me, it's all about the technicals. I know that if I have strong math basics, then I know that I can read any paper that will be in 2018, 19, or 20. And if it's, by the time that you will read about the teachable machines of Google, there will be like BERT number 2 and BERT number 3. Keeping up, it's hard, then. So that's why it's really important that you will be able to understand what you are reading, whether it will be 2 years from now or 3 years from now. The model.fit phenomena will not last for long. It's good for classical models and for general use cases, but when you're coming to solve your own business problem that is a specific use case that you're using, I think that a data scientist should be the one sitting behind the wheel, steering the solution to wherever he wants. That's about sums it up. Unless
just another quick note. I think that many people are kind of like afraid of AutoML. Like, you know, machines run things faster than we do. Let them just try different architectures, different parameters, all of those things. And, you know, we're kind of maybe today helping to build the machines that will make our world work unneeded in a few years. But when you actually work on things, I think that one of the things that senior data scientists do is spend a lot of time not building models, okay, and not tempting to the latest, newest, coolest stuff. And maybe if you approach a problem, being able to, from a large array of very cool models that got published probably because they managed to overfit on a particular data set, the test set of a data set, just kind of understand what can work pretty well for your own problem, your own domain, which is different, which has some things that are similar to what exists and some things that are different. And when you know the fundamentals, it's much easier for you to understand that something might be more relevant to what you do. And this is the big plus we do as data scientists.